Hello, everyone, and welcome to the Construction Methods and Technology course at the NYU Schack Institute of Real Estate in the Construction Management Graduate Program. Welcome, everyone, particularly because this is a hybrid course. I wanted to give everybody the opportunity to take the first class online. That way you could get a little bit used to the lecture types when they're online, and also make sure that all your technology at home works, however you're viewing the lecture. And that you get used to also the online collaboration tool NYU Classes, which we'll use exclusively here at this site to trade information. All of the lectures will be posted there. You can access all of these online lectures at that site. You can access all of the in-class PDFs of the PowerPoints as well as get all your homework assignments and conduct business on the forums and other tools that we'll use in the site. So by getting used to this in the first class, you'll be prepared for the rest of the semester, particularly if this is the first time you've taken a course that has any portion of it or all of it online. So welcome again. I look forward to meeting everyone at class number 2. But for now, this is the first class. It'll be the introduction. We'll go through a couple of different topics. Recordings will be in about 15 and 20-minute chunks per topic. And that way you can go back to something if you want to re-listen to it or re-watch it to get a better understanding of it, or review it. Obviously, if you have any questions, it's easier to get to if it's broken up in chunks. All right. So this first 15-minute portion, I'm just asked as part of the program to give you a little bit of an introduction to myself. And again, I look forward to meeting you all next week and doing this in person. But as for me, I've been a construction manager for 20 years, primarily in the New York, New Jersey, Connecticut area. I've worked overseas for a little bit, and primarily in public sectors. And that's all kinds of work, including high-rises, brownstones, buildings, offices, bridges, tunnels, highways, you name it. I work for a firm called Parsons Brinckerhoff that's located here in New York City and been based here in New York City for about 130 years. So very familiar with the New York City construction environment. And again, have worked in many different areas of construction, but obviously this class will emphasize some of the experience I've had in building construction that I'd like to share with you, and some of the knowledge that I've gained in those 20 years as a CM here in the city. And I hope to give you a good introduction to the methods and practices used in building here in New York City. I've got degrees in mechanical and civil engineering, construction management, so it's a good blend for building work, since, as you know, buildings aren't just civil or structural. There's a big mechanical, electrical component as well, or HVAC, MEP, however you want to call it. If you don't know what those terms are, we'll obviously delve into that a little later in the semester. I advise you to take a look at the syllabus so you can see what our topics are, and we'll go through that in a little while as well. So I've been an adjunct here at NYU for the past 8 years now. I really enjoy teaching and lecturing. Lately, I've been doing the online version of the courses, and this one's kind of a hybrid where half of our courses will be in person. Obviously, the exams will also be held in person at the classroom site, but just about half of our lectures will be hybrid like this. And I feel that's really a great tool because it enables you to get the full class experience and also maybe cut down on some of the time, like commuting to the classroom, and all the ins and outs of commuting in New York City, train delays and traffic jams and things like that. So being able to access half of the classes online, I think, will save you time in the long run to take this course, so you can devote that time to more important things instead of commuting, like reviewing lectures and studying and things like that, or other things in your personal life, which I'm sure are just as important. So anyway, that's why we're doing this as part of a hybrid course. Hopefully it works for your schedule better, especially as I know most of you will probably be full-time members of the workforce who are trying to earn an advanced degree in construction because you work in the construction field. So we understand those restraints and the time constraints, and we're trying to work with you to develop a program that makes it easier to earn your degree and learn what you need to learn. And hopefully it all works for everyone. So I'd like you all to take a look at this lecture, listen to it, see what we've got to offer here in the first class as we go through some of this introductory stuff. And then come back to me next week. Let me know if you had any issues accessing the lectures, utilizing NYU classes, or even getting access to the lectures. So we want to make sure we take care of all of that early on, so that you don't have any issues down the line when we get into the more detailed topics. So just a little bit more about me. Like I said, I've got building experience. I had a pretty significant role on the reconstruction of the World Trade Center Transportation Hub as a project manager for our firm and joint venture. We provided about 8 years of continuous service, everything from construction inspection to 3D modeling, BIM, a whole bunch of buildings trades, project management personnel, coordination personnel, logistics personnel over at the World Trade Center site for the Port Authority of New York. So that's one of the highlights of my building career. Again, I've also done brownstone renovations, worked on federal office buildings and courthouses all here in New York City, so I have extensive building knowledge here in New York City. In addition to that, a lot of transit experience as well. What you see here is the 2nd Avenue subway with the TBM machine under construction for the second tube underneath 2nd Avenue from 96th to 63rd Street. You might not think of that as much of a building project, but when you look at a transit station or facility, it's basically a building that's underground. It still needs all of the facilities. It has ventilation systems, electrical, mechanical, personnel access, interior finish, architectural work, structural work. So it's very, very similar to a building, just underground, and it brings a different aspect to a lot of the building construction. Instead of having a foundation to it, basically it's built within a rock foundation already. And foundations and soils will be one of our first topics. And just a little view of a TBM machine there if you haven't seen one already. And if you live in Manhattan, you're probably very familiar with that project. Another local project I've done here in Manhattan as a project manager, resident engineer, is the 3rd Avenue Bridge reconstruction over the Harlem River. One of the major crossings into New York City. It was one of the first new bridge construction into Manhattan in over 50 years. It's a movable bridge. And what this does, it's a turntable, or what they call a swing bridge, that pivots on the center pier that you see there in the picture right along the middle. And it's basically a big machine that moves. So it, a bunch of gearing, mechanical, electrical control systems, a lot of similarities to what you see in a control system for a building nowadays. It also had a control house that's up top there, if you see that in the middle. Also a lot of interior features, architectural work similar to the building work we're going to cover here. And in addition to that building work, again, New Jersey Turnpike Authority, I've been a project manager for our firm on this project, which widened exit 629 on the Turnpike. So anyone who went down to the Jersey Shore over the summer and didn't encounter the traffic that they're used to, or headed down to Philadelphia and didn't encounter the traffic that they're used to, they had the widening project to thank. It was an amazing project, really broad in scope, 33 miles of basically adding. To simplify it, turning 6 lanes into 12 all the way up and down through that stretch. All right, so we're going to continue on into a little bit of the introduction here. One of my fellow professors, a nice little phrase or saying that he imparts on his students early on, and I've kind of kept to include in this class, is that knowledge is power. We're all here to gain that power, to gain knowledge, to understand things further. And I think that knowledge brings you closer to happiness. We'll see if that's true. But I do like that phrase from a pretty well-respected guy named Thomas Jefferson. So hopefully we all learn, we gain that knowledge, and we're able to use that knowledge on a daily basis to help improve our lives, not only our lives, but the lives of others, the ones who use the buildings in the end run. All right? So we're here to learn. I totally encourage participation in the live classes, asking questions in classes. Please don't be shy. I'll reemphasize that fact when we meet again next week. I want you all to feel safe and supported in this environment. It's an environment to learn. All right, we're all here to learn from each other, me from you and you from me. There's no silly questions. Just please don't hesitate to ask if you don't understand. Or even if you have something to add, please don't hesitate to ask or raise your hand and participate. I want a really lively course, really lively class with you all so that you feel like you're learning and you're really getting the most out of this class. So one other little tidbit just for out of inspiration is you make the impossible possible. I've yet to see the elephant that actually surfs on the surfboard, but hey, if that can happen, we can build anything. All right, just a few notes that I'm required to pass along here, administration, and I'll cover them in this class, so I don't need to hit you with this when we're live in person. But please, again, when in person, have the courtesy to put all the phones on silent. If you need to take a call or a text or shoot a text back, please excuse yourself from the room quietly, take care of it in the hallway, and come back in so we're not disturbing the rest of the students. Attendance at the in-person class is mandatory in this course. I think we'll have about 8 classroom appearances, so you need to attend 6 to get full credit for the course. I obviously would like you to attend all, but we understand that there could be issues that pop up on a Monday night where you won't be able to come in, or whenever extenuating circumstances from something else, work related or not. Just go ahead and shoot me an email. Let me know that you're not coming to the class, and we'll see you next week. So no harm, no foul. But just keep me in the loop. Let me know when you're not coming. That'll be good. As part of this course, there are a number of seminars that you're required to attend, and I'm going to bring in a little more information on that next week. There's a couple that are mandatory for CM students. And again, I'll be in a position to talk to you a little bit more in detail about that next week. But just be aware that those seminar attendances are mandatory. And again, if there's anything outside of the classroom that you want to discuss, and you need to make an appointment, please feel free to email me and set up an appointment, and we'll try to set something up right before or after one of the in-person classes, so that we're both there at the same time. All right. So the objectives of this course are obviously, construction materials and methods. We'd like to get through all of that, including building foundations, the support structures, structural steel or concrete, wood systems, whatever the support structure for the shell of the core of the building are. We're going to go through building systems, everything that gets run in and out of the building, from heating, ventilation, air conditioning, power supply, water supply, sewer. Safety in construction and the built environment. So there's two distinct topics there. Number one is safety in construction and monitoring that. If you're in the construction field, you understand that safety during construction is important. But we also have to realize that there's a lot of things that are included in these building designs and the specifications that allow for safety in the built environment for the end user, and that's part of the consideration of the materials that are chosen for the given building. So it all loops back partially into the materials, but there's a safety element to it as well. Vertical transportation and movement, elevators, escalators, ways to get in and out of buildings and around, stairwells, etc. Then we'll go into the shells and the facades, which is really the protection from the external environment, and enables us to use the building systems to control the environment within that building. And then we'll have the building interior section, of course, with all the finishes, some of the architectural work, layouts, things like that. So basically, we're going to take you through building construction from foundation all the way out through commissioning, testing, and completion, and then really, fit out of the interiors. So, soup to nuts, everything that you need in terms of building materials and building construction. All right, so just as a graphic here, it's like the typical building that's under construction, done in a modeling tool that kind of just shows different levels of work. You see there, the support system is structural steel. They're starting work on the facade. You see foundations are piles, and then all the systems work that start down there on the ground level that start coming up through the building. So just to give you, the global perspective of what we're looking at in building construction, that's basically all of the elements encompassed right there. So again, as part of this course, we're going to study a lot of topics, the materials that we use in construction, the methods used to construct those facilities with those materials, and again, we go from foundations, QA testing, wood, stone as materials, cost estimating, structural steel, again, safety elements of all of this, concrete, facades, roofs, electrical, mechanical, plumbing, fire protection, the vertical transportation element, and interior construction. All with an eye on what we look for in sustainability nowadays with LEED certification and green building certification. We're going to talk to that towards the end of the course, but it is an important thing to keep in mind right now. Just in terms of the structure of the course, again, attendance is taken. As long as you've only missed 1 or 2 courses, it's no big deal. I'd like you to attend all if possible. Reading assignments are important. If you follow the syllabus, you'll be prepared for the upcoming class and understand quite a bit of the lecture if you've read the read-ahead assignments. Those will primarily come from the textbook that's listed in the syllabus. It's an excellent book. I've used that actually when I was an undergrad taking a similar course, so I'm familiar with the book and what's in it. Use that book as a tool just to get prepared for the class. If you have any questions from what you read, you can bring that to the class as well. But the book's really there just to kind of give you a look ahead into what we'll be talking about. So if you're not working day to day in the construction field, you have an idea of what we're talking about, and it'll better position you to understand the topics we cover when we take them on in the class. Every week there'll be a homework or take-home quiz assignment, right, based on the readings usually. Homeworks will be 20% of the grade. The majority of the grades will be based on how well you do on the 2 tests. There's a midterm about halfway through, and a final the week before the last week of the class. During the last week of the class, we'll review the final, go through some housekeeping, and finish up the lectures. So it's very important that you obviously are in attendance during those days for those in-person finals, in-person exams, and that you do well on those, because that is the majority of your grade. Good homeworks and good attendance will help you out as well, but really the majority of it comes from those finals and the grades you receive there. Late homeworks I usually don't accept, but will accept, and it'll basically be accepted with a reduction in grade. If we've already reviewed the homework in the next class, and obviously I'm not going to accept any of the homeworks because we've already reviewed the solutions. All right, again, 2 classes is the maximum allowed of misses. Please try to just give me a heads up, or after the class, shoot an email to me and let me know that you missed the class and everything's okay. I worry that everyone's all right and that you're going to be around for the next class. So if there's anything more long-term than a one class, please seek me out and speak to me about it. And again, the easiest way to contact me is via email, rmm299@nyu.edu. That's on the syllabus as well, so email's the easiest way to keep in touch with me, especially when we have 1 or 2 weeks in between live classes. Grading will be based on your actual raw score on the exam. I'm not planning to curve. I think the exams are fair enough that if you've studied the material and understand it and are ready for the exam, you can achieve 100. So I expect that there will be a lot of high-scoring students in the class, so it won't be possible to really curve the grades. And the final grades, as far as letters, are assigned per the NYU grading policies. You can find those online at NYU, but basically, more or less, it's 93 to 100 equals some form of an A. I think it's 85 to 93 is some form of a B. But basically, it tells you what to expect. So if you know your grades on these exams and you know your grades on the homeworks, you'll know what your overall class letter grade will be. So there won't be extra credit assignments. I just want to try to head that off at the pass right now. In the past, people who didn't give the course the attention and detail that it needed early on started trying at the end to figure out ways to try to improve their grades. But it's really not fair to the other students who put the time and effort in from the very beginning to try to get a good grade. So I don't entertain extra credit. Please have your assignments in on time. If they're more than a few days late, they won't be accepted because, again, we'll have talked about solutions in the next class. And again, I'm here to work with you. I don't want to make your life hard on this. I want you to learn. So if there's any issues in attendance or something more long-term, please seek me out and speak to me about it. All right, for in class, I expect everyone to be on time. I understand that, again, commuting can be an issue in the city, and you may or may not arrive on time all the time, and that work is definitely a priority and might be a priority over the course. So try to be on time. If you can't, please enter the classroom quietly and out of respect for your fellow students. Try to read ahead those assignments. Again, it'll help you be prepared for the coming classes. So try to keep up with the readings. Please submit good, well thought out homeworks. If it's anything that requires showing work, show me that work so I can get you partial credit and do the best I can to give you the highest grade possible, even if the final solution isn't right or There's a little you missed something here and there. If you let me know what you're thinking and you show it to me, and I know you got the logic behind it, I can still even give you full credit for it. So don't be shy in showing me your assumptions and working things out on the homeworks. And again, I'll leave this up here for a minute for you to read. I don't expect anyone to have issues with this, or I don't expect to remind anyone of this stuff in class. We're all adults here. We should be able to conduct a real good class and have fun doing it. All right. Again, this is just some what I call housekeeping. Again, this is the qualitative standards for grades. What your letter grade should signify you accomplished in the course. And then following this, you can review this, of course, at your leisure if you want to pause this, but we'll move on. This is the grading scale. Again, here, there it is, 90 to 100 is some form of an A, anywhere between 80 and 89 is some form of a B. And that's basically what we'll do. It'll be all calculated based on the raw scores in your exams and your homeworks. So when you think about it, even if you get full credit on both exams, the best you can do is an 80 because they're both 40% of your course. So you have to pay attention to those homeworks as well. Make sure they're handed in on time and complete, and you can earn a really good grade. All right, so I'm going to get out of this preliminary stuff and the intro of myself and the course and our expectations, and then the next section here will be based on some introduction to buildings. So we're going to end this portion right here and then start recording the next portion. So I'll catch you in a minute, continuing on from this slide. Okay, let's continue on with the second part of lecture number 1 here. And we're just going to go through a little bit of an exercise here and trying to understand buildings, building systems, and relating them to your body. Just a quick exercise here and getting an understanding of all the intricacies of what go into a building system. All right, so you take a look at this picture here, and we try to relate certain systems in a building to the body to gain a better understanding. What does the roof of a building generally provide? Coverage to keep the rest of the building cool, to shade you from heat, and also to provide defenses against rain, sun, snow, etc. So it serves as that top of the building or the base of the head. The brain is the electrical system, okay, what basically runs and operates the building, whether it's through a programmable logical controller or some kind of BIM module. We'll talk about that, building information management systems, BIM, and what that does to control and regulate the systems within the building, not only temperature and airflow, but also could regulate things like water, plumbing, and again, things like airflow and heating. Within that body, there's the organs, which is kind of like the mechanical systems, things like plumbing, boilers, piping that goes in and throughout the building, much like you have organs and intestines and stuff within the body. So that's kind of like the mechanical systems of your body. The skin serves as the building enclosure. All right, whatever that skin is made out of, it could be windows, it could be paneling, it could be brick, any particular material that's on the facade of the building. And again, that's a form of protection of what's inside the building. Keeps you sheltered from whatever's on the outside from the elements. All right, the plumbing system, excretory system, that's kind of funny one. So basically, that's the internal plumbing of the building. All the waste needs to be carried out of the building into the sewer. Similar to that system in your body. The skeletal system of a human frame, very similar to the structural system in a building. It's what holds you up. It's the strongest material. It's the bones. It's basically what keeps the rest of the body and all the other systems standing. All right, so it keeps the building upright, keeps the building standing. And then the feet are similar to the geotechnical components of the building, the foundations. You need a good base to stand on. Without the feet, it's not likely, or a good firm footing, the building's not likely to stand. So from the ground on up, that's just a little comparison to what the systems in the body are to the systems and elements of a building. Right. So we know that within a building, we have to keep the temperatures comfortable. Otherwise, there's no use in being within the building. You may as well be out in the elements and exposed to the elements. So the body cools by evaporation, sweating. When it feels hot, it finds a way to get rid of that excess heat. In the winter, the body constricts a little bit, keeps the blood away from the skin area so that it can keep the key components of your body warm. So that's how you manage heat within the body. And then the fat acts as an insulator. So all of those are similar components to what we would use within a building. And again, just a quick graphic to kind of put that into perspective. And I kind of like that analogy, to compare the two, because it gives us a firm grip on what everything's supposed to do. So basically, we're going to deal with materials in this course and the methods of how we use them to build a building. And we have some very basic building materials, and this goes back in time and hasn't really changed in a number of years. Some steel has gotten slightly stronger. There's different alloys and components of metals now that are used that are a little lighter and a little stronger than before. And the same for concrete. There's different mixes, different applications. Some of them are flowable, some of them are harder. When installing them, some can get into crevices and others you need larger areas for. But more or less, the materials we use now aren't much different than the materials used 100, 200 years ago. Wood, stone, brick, concrete, steel. It's how well we use them and how well we fabricate them that determines how successful we are sometimes on a construction project. And that's handling of the material, basically from fabrication, from raw elements of that material. If it's not something that's found naturally, it's the fabrication to make sure there's quality assurance and quality control through that process, all the way through protecting material on delivery, proper handling when it's delivered, proper installation, and then basically then you're on your way to being successful in using these materials in construction. Every material has a strength and weakness. There's no perfect material out there that can be used for just about anything. So that's why you see so many different forms of construction. Some materials are too expensive for certain uses. Some materials are cheap but aren't strong enough. So there's always you always have to weigh the advantages and disadvantages in regard to the material you're choosing for your project on the engineering side. And then when you're constructing it, you have to have a good understanding of how to use that material properly to be able to properly construct it. So materials come down to basically how they handle loads and stresses. Each material, again, has that strength and weakness. Whatever material you choose for your application has to be strong enough to sustain those stresses. Right? So a lot of what goes into that is not only the material, but also the shape and the dimensions of that material. And we'll study that a little more in depth as the class goes along. But it's common sense. Something that's if you take a rock, it's going to be harder. If you have one that's made out of hard material that's bigger, it's going to be able to handle a much larger load than one that's smaller and made out of softer material. So you could take that into account in almost any material we talk about in this class. So, basic understanding of engineering. There's the neutral axis is more or less the center of the material, whether it's a concrete structure or a steel beam or a wood 2x4. Okay, the longer the material, or the longer the the longer the material from end to end, the stronger it needs to be to hold. It needs to hold a certain weight. If you've got a short distance from end to end where it's being supported, and it's a weak material, it can probably hold a larger weight than if you had that same material expanded 2 to 3 times the same length. All right, so you picture a board supported between 2 concrete blocks, right, or a horse structure, or anything of that nature, and that point load in the middle can be a lot heavier if the supports are closer. But the further the supports go out, the stronger that material has to be to hold the same weight. Two other concepts to introduce you to and to get out of the way now is tension and compression. And these two act interchangeably and together. If something is strong in compression but bad in tension, it's good for certain uses but not others. What materials out there that are good in compression, basically? What materials are hard to reduce their length when you push on both ends? So you think of things that are very stiff, very hard, very rigid, things like concrete, bricks, steel, can be good in compression. Others are good in tension. Steel is not so good in compression, but it's very good in tension. It has good strength even when it bends slightly. So that's why you see steel used as the frames of buildings and the frames of bridges, because they're exposed, the steel frames are exposed to forces. And these forces are generally, regarded to either weight or wind. Buildings have to be somewhat flexible to encounter wind loads. If there's a strong wind load and a building wasn't flexible, it would snap. So basically, tension and compression work together, and that's why you see concrete and steel used together as materials for building. Concrete roads. Concrete on the outside to deal with the compression of the weight of traffic. Tension, steel reinforcement bars on the inside so that if there is some flex due to that weight, the steel takes the tension and the concrete doesn't just crack and fall off and break. So the tension and compression are a couple of concepts. Again, concrete not very good in tension. Steel great in tension and somewhat good in compression, but not as good as concrete. So that's why the two make a good teaming partner for many of the construction aspects that you see here. So majority of the buildings we have out there have concrete and steel elements of the structure, as well as bridges and roadways have steel and concrete working together in tension and compression. So just a quick history on structures. Okay, we all look around us if we live in a city and we see structures everywhere. We can tell what's an older structure from a newer structure basically by the facade of the building and the materials and the construction methods that we see were used. This takes us back to the pyramids. Okay, so these are the oldest existing structures on the face of the earth. Okay, getting in excess of 4,500 years old, and they're still standing. Some of the greatest construction projects and feats ever in history. It's amazing, just the amount of time that they've lasted, and the immense effort that it took to build these things. They're not small. They're not made of small, light materials, and they're basically built to tolerances that we would use today in high-rise construction. So just when you think about it, the pyramids are basically 2/3 the size of the Hoover Dam in height, and we all know how great and majestic the Hoover Dam looks. Labor, it's estimated by the historians and archaeologists that it was over 13,000 people building this structure. So you know how labor intensive it was. They didn't have cranes, they didn't have bulldozers, heavy equipment, excavators, you name it. So all of this was physically done and done through pulleys and the use of math and engineering. All right, so today, we've accomplished a lot in 4,500 years. We've gotten to the point that we can now build structures that are nearly 3,000 feet tall. So the largest building to date completed and open and used as a structure is Burj Khalifa in Dubai, completed in 2010. There's a couple of really, really super tall buildings that are under construction right now between China, Qatar, Dubai that may exceed that. And we'll see if they can successfully construct those and get those open and used in the same manner. But you can see how even in just the last few years, you take the last 15 years where Taipei 101 was once the largest building, or one of the largest buildings, and the Willis Tower here in Chicago was one of the largest buildings. We've almost, doubled that in terms of the last 15 years of construction. And again, that's, improved materials, um, improved alloys, different strengths, lighter materials, lighter construction that can take it up higher, that still has the strength and flexibility to withstand the impact of wind and other loads that you get at that height. So it's really amazing how, all of a sudden now there's such a large emphasis on building and structure construction in cities again. If we all think about it, whether, we haven't met yet since this is the first class and it's online, but, whether your parents or a generation before that, grandparents, depending on when they grew up, people were trying to get out of the cities. The dream was that that house and the 2.5 kids and land to call your own and some place to park your car and stuff. And you look at what the recent trend is that people are flocking to the cities again. They don't mind living in smaller spaces. They don't want to own land. There's not a need for a car because you have public transportation. It's better for the environment not to have your own car and to just work within the city. You have more things at close access if you live in the city. And it's almost generational. It kind of sways and swings. And, one generation wants to move out, the next generation wants to move in. And it's almost cyclic. But right now it's getting to the point where this generation is looking towards the city for lifestyle and employment. So to fit more people in our urban environments, the only place to put them in most cases is higher. All right, that's why you're seeing so many building. If you look around New York City, you see cranes everywhere. You see new construction everywhere. New buildings for offices, new buildings for housing. Just so that people can be closer to the city, and the cities are growing at an incredible rate right now. So there's a trend. There's now again an emphasis on being able to build higher and faster so that more people can live in a smaller area of land. So it's a good time to be in the building construction industry, particularly in New York. A few years ago, in the 2010s, 11s, 12, things were a little bit slow. The economy was in a downturn. There wasn't as much investment into buildings and real estate. But now that the markets have been on an upswing over the couple of years, that money has returned, and the investments just keep on rolling in again. So tons of construction work, tons of building work, anywhere in an urban environment, and you should be well positioned after this class to be able to move forward into the construction and management of those high-rise buildings. So again, 480 something feet high. Just an amazing structure, almost perfectly built, angles, tolerances to shape, incredible construction feat, just incredible. All right, so just a couple of statistics here, but really the takeaway from all this is the fact that again, this construction was performed without the use of diesel-powered machinery. All right, this was all person power, working in unison to build this, and just very strict tolerances. So there's probably a site superintendent that had a real grasp and knowledge of the project, and was hovering over the labor force to make sure that this was placed exactly, every block, every stone was placed exactly where it needed to be. So it was really was just an amazing feat between the physical construction and the engineering that went into doing this. Not to mention the fact that it was built in a very tough setting, in the middle of a desert. Heat, wind, sandstorms, you name it, that was probably encountered during the construction of the pyramid. So, if you haven't given appreciation to what was constructed 4,500 years ago, I hope that gives you a little bit of a flavor for it. And the actual tolerance here, 1/2 inch out of plumb on a 481 foot structure. So when you think about that as far as percentage, that's, of the strictest of tolerances, it's like 0.00001. So just to give that some perspective, even with modern technology, materials, extremely trained workforces, we sometimes can't get a tolerance that's that close to exact. Excuse me. So, again, just seeing a meeting point between the two blocks and how tight the seal is between them. Those rocks have to be, of course, over the years, if there were any gaps, they're probably closed, through the use of gravity and wear and tear under friction between the two slates. But you can rest assured that each of these huge rocks of granite or marble were somehow finished down a little bit using hand tools, stones, other materials, and tools to make this seal and fit proper. You wouldn't see any daylight inside these pyramids, which were basically tombs. All right, so let's take a few minutes here to reflect. And again, we talked a little bit about how we can go much higher now with building 6 times what was built back in the days of the pyramids. But when you think about it, over 5,000 years ago, 4,500 years ago, that's only a 6-fold increase in height of structure over that length of time. So, as much as I'd like to say things have changed, they're not that much different. All right, things may have improved, but they're really very similar. A lot of the same concepts are used. A lot of the same building material is used. Obviously, that's made out of stone, right? A lot of the same engineering goes into place to calculating and being able to figure out loads and how to shape them to be able to withstand the test of time and the elements. So how is construction today similar? There's probably 100 bullet points we could put out there, but take a few minutes right now to just think about that. Maybe jot them down, and I'll go through a couple of these that cross my mind in a few minutes when we fill out this chart a little bit. All right, so just take a couple of minutes, try to jot down a few things that you think are similar between today's construction and construction 4,500 years ago.